when I grade it, what I'm grading. So we've got a sheet of notebook paper out. We have labeled it homework practice problems, and we are going to do these 4 problems right here, at least the first 2. So the next time we're together, I'm going to hand you a quiz, and it is going to have a problem, just one problem on it, just like this one. So tell me what you're going to do to get started. You are writing this down on this notebook paper. Step 1, factor it all. So the top factors easily, and the bottom factors easily. So when you get your quiz paper on Thursday, the first thing you're going to do is factor anything that factors. Now what? We can cancel. That simply means that my problem is going to have a hole. The directions on the worksheet say label all. So you're going to label this hole. Where is this hole going to be? It's going to be where x is -4. Because that's what canceled out. How do you get the y? Plug it in right here. So if we plug in -4, on top we get -1, and on the bottom we get -8. So my hole is at -4, 1/8. Now, if I've done something you're not sure about, now's the time to ask. Because you have to do this on your own Thursday. Okay? Alright? What else? It says sketch, label all. What else do I need to put into my picture? Vertical asymptote. And where will that be? X equals 4. Because vertical asymptotes happen when the denominator is 0. All right? Joseph, what else goes into the picture? I need a horizontal asymptote. And where's that going to be? Now watch it. It won't be y equals 1/8. Look right here. No. Y equals what? 1. X over x. That's how you find your horizontal asymptote. Remember, you put power over power. So x squared over x squared, or x over x. Your horizontal asymptote is at 1. Now, Joseph, he didn't know exactly what he was going to say, so he was throwing out numbers. And he threw out -3. -3 is an important number, right? It came from the numerator, -3. How does that show up in my graph? What's -3? X-intercept. So there's going to be an x-intercept at -3. Now I have everything except my y-intercept.
0 and 3, -3.
How do I get a y-intercept? I let x be 0. To find my y-intercept, I'm going to let x be 0. And if I put in 0, what do I get? Put in zeros for your x's. What do you get? 3 over -4, -3/4. So you have a y-intercept at -3/4. Now somehow from this you need a picture. Remember, all the points are connected. Does that help you visualize it? If they're all connected, don't we have to have a shape kind of like this? And if that's what you put down, you're going to get some credit, but you're not going to get all the credit because what's missing? The other one, the other piece. Where's the other piece going to be? Up here. Remember how they're usually opposite each other? I'm not going to give you some funky picture. They're usually reciprocal function, opposite each other. All right, we got it? All right, one more. Do the second one. Try the second one on your own. You're going to turn this paper in when you turn in your homework. So let's get number 2 finished. See how far you can get with it. I'll work on it up here and we'll compare. Pretend this is your quiz question. Before you start graphing, double check and make sure you match my factoring. I have factored and canceled. Make sure you match me. It's going to be embarrassing if I made a mistake. Double check. I don't think I did. Yep. Somebody just asked, did I start by pulling out the 2? And the answer is yes. When I'm factoring, I always take care of my GCF first, my greatest common factor. Any other questions? Yeah.
It should be 6x.
Uh-oh, it should be what?
6x. Or like this one creation. Minus 6x instead of the 3. Oh wait, you're right.
But I took out a 2.
Oh, never mind, I see what you did.
Yeah, thank you. That would be deadly if I copied it wrong, but I pulled out a 2. Okay, are we okay to this point, everybody? Are you working ahead? What are you doing? What are you working on? What are you figuring out? Have you figured out there's a hole?
Yeah.
Where will it be? There'll be 1 comma something. Have you figured out the something?
No. -106.
Okay, I heard a -1/6. I'm going to write that down, but I'm going to double check it. If I put in a 1, I get 2 times -1 over 6. I think it's -1/3. You may want to agree or disagree or talk about it or ask a question. I put in 1 here, so I have 2 times -1 over 6. Marley, did you forget the 2 maybe?
I don't know.
Would you agree it's -1/3? If I put in 1, I get -1. 2 times -1 is -2 over 6. So I have a hole at 1 comma -1/3. All right, have you worked ahead? Have you gotten anything else done? Vertical asymptote, where'd you put it?
-5.
At -5. We have a vertical asymptote at -5. Groupies, you just gotta remember vertical asymptotes come from whatever makes the denominator 0. And what makes the denominator 0? -5. Alrighty, what else?
Horizontal asymptote is 2.
I have a horizontal asymptote at 2. And again, you've got to remember that to get horizontal asymptotes, we can either go back to the beginning problem and compare 2x squared over x squared, or we can compare right here in our reduced problem, 2x over 1x. Either way, 2x over 1x, you get y equals 2. All right, what else have you put in here? What's this numerator tell me? It tells me 2 is a special number. That's my x-intercept. So I have an x-intercept at 2. How do I get my y-intercept? I plug in 0. So what happens to get my y-intercept? I'm going to plug in 0. So what do I have? 2 times -2 over 5? -4/5. Emily?
Where did you get 2 for the x-intercept?
What makes this 0?
Because you know, they like the 0.
So you don't have to do anything with the 2 out front?
Okay, if I put 2 in here, 2 minus 2 is
0.
and times 2 is still 0.
Okay.
So no, I don't, because I'm multiplying by 0. Now, can you sketch it? Hopefully you can. You want full credit, you better do something else though, right? That's not enough, Ethan. What's missing? So where do I put that? Top left, right here, very good. That's going to be the other piece of the graph. Bailey.
So when we graph it, when we're graphing the line, does it
It should not touch the horizontal line. Now, some of those weird ones we did crossed in the middle here when we had like 2 asymptotes and stuff, but the ones we're doing, these very basic reciprocal function type things, should not touch it.
Okay.
It gets closer, farther you go, closer you get, but it's not going to touch it. Okay? That is your quiz. One problem like that is your quiz on Thursday. Everybody clear? We're going to finish this sheet so that'll be done for your homework. So those of you that never do any homework, at least you'll have this done because we will have done it, right? So let's take a look at it and see. I need a marker. All right, number 3. Oh boy. Number 3. Do you remember doing problems like this back in first year algebra class?
Yeah.
To do a problem like this, where Susie's doing a job and Billy's doing a job and they can do it alone or they can do it together, that kind of problem, there's a formula for, and it's 1 over alone plus 1 over alone equals 1 over together. Now kids, these problems are an absolute cinch. Literally, first year algebra. If you remember 1 over alone plus 1 over alone equals 1 over together, you cannot miss this problem. Let's see. Amelia can paint a room in 4 hours. 1 over 4. Because what's 4? Amelia's time alone. With Aaron's help, it takes 1 hour. All right, now what's the 1 hour? That's their together time. How long does it take Aaron alone? 1 over x. There's the equation. It could not be any easier. It's never any different than that. 1 over alone plus 1 over alone equals 1 over together. Now, are there fractions in that problem? Yes. We want to get rid of those fractions. So I am going to multiply everything by what? What will it take to get rid of every fraction?
4.
It'll take a 4, but also an x. If you want to get rid of every fraction, you have to multiply by both denominators, 4 and x. So what am I left with here?
1 over x.
No, not 1 over x, 1x. There is no denominator. It is gone. So x plus 4 equals 4x. So 4 equals 3x if I subtract x from both sides. And x equals 4/3 hours. So how long does it take Aaron alone? 4/3 hours. Now we'll practice some more of those, but we really don't need to because they're so easy. Last one, and then I'll be quiet, okay? I'll shut up. Let's do this last one. Number 4. How much, oh my gosh, have we done these before?
Yes.
What's our formula?
Amount times percent.
Amount times percent
Plus amount
times percent
equals amount.
equals amount times percent. All right, let's start plugging it in. How much 16% solution? Does that look okay to everybody? How much x 16% should be mixed with 9 quarts of 2%, and when you write 2%, it's 0.02, right? Not 0.2, 0.02. To get a 10% solution. Now, be smart. What goes here? If you said x plus 9, you are right, because that's the total. And if you are mixing together x and 9, then the total would be x plus 9. So 0.16x plus 0.18 equals 0.10x plus 0.9. And there's 6x. You can use a calculator. Whoopsie, something's wrong. Oh no, never mind. You can use a calculator. I got 12 quarts, but I'm gonna let somebody with a calculator check me on that.
How did you get from 17? Did you multiply?
Subtracted 0.18 from both sides, collect like terms, that's 0.90, so I subtracted.
Oh.
Right, remember, you can use a calculator. Anybody who worked it out, get 12 quarts? Okay, we've got 8 minutes left, and here's what's gonna happen in this next 8 minutes. If you want to staple the sheet we just did to the word problem worksheet, since they're both gonna get turned in, feel free to do that so that you don't lose them. Both those will be turned in. If you would like to do an extra practice problem for the quiz on Thursday, I will put it on the board. You do not have to do it. If you have something else you want to work on, or if you're Nick and